Hi students, this is Alex here. In this video, they have given a homogeneous rod of conducting material of length L has its ends kept at zero temperature and the temperature at the center is T and falls uniformly to zero at two ends. So we have to find U of x comma T. So let's write the initial conditions. We have a small diagram, that is we have horizontal axis and vertical axis. In horizontal axis it is the distance x, so there is a rod of length L. So let's take this as end A and this as another end B. The entire length is L and in both the ends are kept at 0 degree centigrade. So initial and boundary condition we are going to write U of 0 comma T is 0 for all T greater than 0. Similarly, the other end U of L comma T is also 0 for all T greater than or equal to 0. Even this I can take greater than or equal to. Now the third condition is U of x comma 0, that is as per the condition at the center the temperature is T. So if I take here the temperature at the center, it means here is the center L by 2. So the temperature is T. So we have a diagram like this. So like this, here the temperature is T. So we can mark this point as C and it is L by 2 comma T. And again it gradually falls to 0 on both the ends. So again it has to come like this. Now I have to find the equation of AC and CB, and that will be here our function U of x comma 0. So one will be from 0 less than x less than L by 2 and other will be from L by 2 less than x less than L. And even if I take less than or equal to, it is same. So I have taken less than or equal to in every case because it is also equal to 0. I cannot put only less than. Now let's find the equation of AC. So equation of AC, A is actually 0 comma 0 and B is L comma 0. So equation of AC, we have A as 0 comma 0 and C as L by 2 comma T. So for reference, I take this as x1 y1 and this as x2 y2. So we are going to use a 2-point formula. Y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1. So y minus 0 by t minus 0 equal to x minus 0 by L by 2 minus 0. So this is y by t equal to x by L by 2. 2 I can take here and L I can bring here. So from this finally I am getting y as 2t by L x. So I have to write 2t by L x for the first part. The same way I have to find the equation of CB. So point C is L by 2 comma t and B is L comma 0. So now this is x1 y1 x2 y2. So y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1. So this will be y minus t by minus t equal to, by taking LCM here, this is 2x minus L by 2 and denominator L minus L by 2 is L by 2. So this gets cancelled and I can carry this t to the other side or I can cross multiply. So y minus t into L equal to 2x minus L. So now this is Ly minus TL equal to 2x minus L. I can take this to the other side and even here when I cross multiply minus t will be coming. So here also minus t will be coming. So if I write Ly minus TL equal to minus 2tx plus TL. So I have to take this term to the other side. So Ly equal to, if I take this to the other side, it is TL. Already there is one more TL. Then minus 2tx. So this is Ly equal to 2TL minus 2tx. I can take 2t common, it is L minus x, and here y will be 2t by L into L minus x. So we take this here, 2t by L into L minus x. 2t by L into L minus x. So this is the function we got. Now let's write the heat equation. The heat equation is dou u by dou t equal to alpha square dou square u by dou x square. Now we have a suitable solution for this. The suitable solution is u of x comma t is a cos px plus b sin px into e power minus alpha square p square t. Now we are going to use the first condition, that is u of 0 comma t is 0. So wherever x is there, I have to substitute 0. So when I substitute 0, we get u of 0 comma t is a into cos 0 is 1 and sin 0 is 0. So we have only a e power minus alpha square p square t, and this value is 0. So 0 equal to a into e power minus alpha square p square t. Here e power minus alpha square p square t is not equal to 0. Therefore the only option is a must be 0. This a equal to 0, we have to substitute in our solution. So u of x comma t will be, when a is 0, this part will not be there. We have b sin px into e power minus alpha square p square t. Now we are going to use the second condition. So using second condition, u of L comma t is 0. So wherever x is there, I have to substitute L. So this will become u of L comma t is b sin pl e power minus alpha square p square into t. Now this is 0. So 0 equal to b sin pl e power minus alpha square p square t, and already we discussed e power minus alpha square p square t not possible to be 0, and b also cannot be 0 since a was 0, because out of the two terms any one constant can be 0, both constants cannot be 0. So already a is 0, so b cannot be 0. Therefore the only option left is sin pl must be 0. When sin theta is 0, theta is equal to n pi. So this PL will be equal to n pi, and from this the value of P is n pi by L. This we are going to substitute back in our solution. So u of x comma t will be, u of x comma t will be b sin px. So n pi by Lx e power minus alpha square p square, which is n square pi square by L square into t. Now coming to the rearranging, this can also be written as summation from n is 1 to infinity, the constant is bn, and we have sin n pi x by L e power minus alpha square n square pi square by L square into t. Now let's use the third condition. So using the third condition, in third condition we have u of x comma 0. So wherever t is there, I have to put 0. So u of x comma 0 will become summation n is from 1 to infinity bn sin n pi x by L, and when t is 0, we will get e power 0, which is 1. So we have only this much. And on the other side, u of x comma 0, we have a function which is 1 is 2t by Lx. So here it is 2t by L x when 0 less than or equal to x less than or equal to L by 2. Other one is 2t by L into L minus x. So 2t by L into L minus x, and x ranging from L by 2 less than or equal to x less than or equal to L. So we have this function summation from n is 1 to infinity bn sin n pi x by L, and this is the half range Fourier sine series. So we can write this is half range Fourier sine series. So we can find the constant Bn using the integration formula 2 by L integral 0 to L f of x into sin n pi x by L dx. Now we are going to substitute the function, but function is made up of two parts. So we take Bn equal to 2 by L integral first 0 to L by 2 alone, and f of x is 2t by L x into sin n pi x by L dx. This is the first part. Then again 2 by L integral, now L by 2 till L, and f of x is 2t by L into L minus x into sin n pi x by L dx. So here this 2t by L is a constant that can be taken outside the integration, and we are going to use the Bernoulli's formula. This is u and this is v. So u equal to x and v equal to sin n pi x by L. So u dash will be 1, u double dash will be 0, and v1, this integration is minus cos n pi x by L by n pi by L, and v2 will be minus sin n pi x by L by n pi by L whole square. In the same way, so coming to this is u and this is v. As usual, 2t by L can be taken outside because it is a constant. So we have written u and v alone. Now u dash will be minus 1, u double dash will be 0, and v1 is minus cos n pi x by L by n pi by L, and v2 is minus sin n pi x by L by n pi by L whole square. Now the Bernoulli's formula is u v1 minus u dash v2 plus u double dash v3 dot dot dot. So we start writing Bn. Already there is 2 by L outside. When this 2t by L is taken outside, it is 4t by L square. So 4t by L square, then open bracket. So 4t by L square is taken. Then we have to apply this formula u v1. So x into v1 is minus cos n pi x by L by n pi by L, minus u dash is 1, v2 is minus sin n pi x by L by n pi by L whole square. Now this is 0 to L by 2 plus. The same way, second term also we can take this constant 2t by L outside, and this if I multiply I will get 4t by L square outside. So 4t by L square we can keep it outside, 4t by L square, and now this is L minus x is u in the second part, and we have v1 minus cos n pi x by L by n pi by L, then minus u dash, but u dash is already minus 1, so I can make that as plus 1 into p2 minus sin n pi x by L by n pi by L whole square, and we have limit from L by 2 till L. Now applying the upper limit, so wherever x is there I have to substitute L by 2. When I substitute L by 2, outside 4t by L square is kept, and this will be L by 2 into minus cos, when I put L by 2, L gets cancelled, we have only n pi by 2 by n pi by L, and we can cancel this and make this as plus, and now this is sine n pi, after placing L by 2, L gets cancelled, so we get n pi by 2 by n pi by L whole square. When I use a lower limit, because of this x it is 0, because of the sine it is 0, because sine 0 is 0, so lower limit all the values are 0. Coming to the second set of terms, I have to substitute upper limit L. So when I put L here, L minus L is 0, and when I put L here, LL gets cancelled, sine n pi is 0. So totally upper limit is 0. When I put lower limit L by 2, L minus L by 2 is L by 2. So L by 2 into minus cos n pi by 2, because L gets cancelled, n pi by L, then here it is minus, we have a minus sign, sine n pi by 2, because L gets cancelled, n pi by L whole square. So we completed the lower limit. Now we take totally 4t by L square common, write the rest of the terms. The first term is minus L by 2 into cos n pi by 2. Second term as it is sine n pi by 2 by n pi by L whole square. And here we have a denominator by n pi by L. Then here this minus sign comes inside. So plus L by 2 cos n pi by 2 by n pi by L. Then again this comes here plus sine n pi by 2 by n pi by L whole square. Now we see that two terms are same but opposite sign. So L by 2 into cos n pi by 2 by n pi by L. One is plus, other is minus, so we can cancel. Now finally we can add the other two terms. The other two terms, when I add, already we have 4t by L square. It will become 2 sine n pi by 2, and denominator we can expand, n square pi square by L square. That L square goes to the numerator, we can cancel this. So finally we get Bn, which is 8t sine n pi by 2 by n square pi square. So we got Bn. This we are going to substitute back in our solution. So u of x comma t will be summation n is from 1 to infinity Bn, which is 8t sine n pi by 2 by n square pi square. Then here we have the solution part. So we substituted the Bn. Then sine n pi x by L we have to write. So here it is sine n pi x by L. Then e power minus alpha square n square pi square by L square into t. And the constants can be taken outside the summation. So u of x comma t will be 8t by pi square is taken outside. We have summation n is from 1 to infinity. Then we left with 1 by n square. Then sine n pi by 2 into sine n pi x by L into e power minus alpha square n square pi square by L square into t. This is the required solution.